Okay, so now I'll take a look at example 3. Okay, so example 3, basically, you get your parent function, okay, which is 1 over x right here. And what we want to do is find f of x plus 3. So basically all we do is take that parent function, 1 over x, because that is f of x, and we're going to add 3 to it. So it's just 1 over x plus 3. That's the new function. And so we go to the transformations, right? So nothing's being done to this x down here. And the plus 3 just sends it up 3 units. So what that's going to do with the asymptotes, so for the vertical asymptote right here, because it doesn't go towards the left or the right, it's going to stay put at x equals 0. So it's just like the parent function. No left or right movement means that we stay put at x equals 0. However, because I do move up 3, that's going to affect my horizontal asymptote in this case. So since we move up 3, we're going to take the y equals 0 from the parent function, add 3 to it, so we get y equals 3. Okay, and that sends us to this horizontal asymptote, the blue line right there. Okay, so if you want to take a look at this with the graphing calculator, so again, y1 just has the parent function 1 over x, and then over, it's like in y2, we put 1 over x. Notice we don't put parentheses around 1 over the quantity x plus 3, because that would be telling us to move to the left 3. That's not what's happening, so we don't have to put parentheses. So we just put 1 over x plus 3, and we're good to go. If you take a look at the graph, parent function is in black. All that plus 3 is doing is moving it up 3 units, and you can see what's going on with the red. So if we go back to the actual notes, again, just do the quick graph with this green right here. You don't have to be exact. We don't have to really use the table with the exact x and y. So if we take a look at the domain is actually using the vertical asymptote. So we looked at the graph from left to right. So from the left, I'm starting at negative infinity. I'm stopping at that vertical asymptote, which is at 0. Starting up at 0 and going to positive infinity. Okay, and that's just how you write that in an interval notation. So negative infinity comma 0, put the unit symbol, and then 0 comma infinity, and stressing the use of these parentheses here. Okay, range, we're going to look at it from down, which starts at negative infinity, and then we're going to follow it up to the horizontal asymptote, which is at 3. So that's why you have negative infinity to 3. And then we got to start back up at 3, and it goes on forever. So, we can write those arrows down on that graph as well. So that's the range. We already did the transformations. I always start with that because it helps me to identify the vertical and the horizontal asymptotes really easily. And then and behavior, basically when the x is approaching infinity, so these two are consistent always. You're basically telling me where the y is approaching for every single one of these. So as x approaches infinity, so is the x getting bigger. Okay. The y value is just approaching that horizontal asymptote, which is 3. And the same thing's occurring when the x values get smaller. So as they approach negative infinity, y approaches 3 as well. So that really takes care of example 3. So I'll stop this video here.